So, uh, welcome back. Today, 2.2 was covered in my 154 courses. So, what I'm going to focus most of our day on will be just calculating more weighted averages by hand. So, we're not going to be doing anything with Excel. We're just going to be practicing more stuff by hand. But first, last class, I had mentioned there was a problem in that the proportion set homework, the week 4 stuff that we skipped over. And I want to do that one problem first. And the only reason we skipped over it at the time was because it was going to take 10 or 12 minutes and we didn't have the time for it. So I wanted to focus on things that were shorter, but we do have time today. So what I'm going to do is I've already pre-recorded that section. I'm going to play that video. So again, just a quick problem, that thing with calories and whatever else with some fractions, if you remember it, when we just kind of, like I said, skipped over it. And then we will get into some more weighted average examples. All right.
All right, so this problem, when we were doing the proportions and setting things up, we got to a word problem, and it had fractions in it, which was the main reason I said this one's a little above us at the time. And I don't want to mean above us. It was just we had like 10 minutes to do it, and it was going to take more time to explain. So remember, the idea behind proportions is you first want to write a fraction in words. So first over second, apples over oranges, whatever. And then you just need to have one side of the fraction be exactly that for one scenario, and then the other side of the fraction be apples over oranges for the other scenario. Generally, one of those 4 spots will be a variable. You cross multiply and solve to find the unknown. So let's read this problem since it's a new day. The nutrition information on the cereal box says that a third of a cup serving provides 100 calories and 4 grams of dietary fiber. So no specific cereal, third of a cup. So when they say a third of a cup, they're talking about in terms of weight, not actual liquid volume. That would be fluid ounces. There is a difference between cups of fluid ounces and cups in weight. So they say 100 calories for the third of a cup and also 4 grams of dietary fiber. So you scoop out 1/3 of a cup of cereal and you're getting this many calories, this many grams of fiber. So at this rate, and when they use the word rate, that means everything's proportional. That's another clue or another keyword. Find how many calories and grams of fiber are in a 1/2 cup of serving. So this is one of the 2 reasons, or the 2 reasons this problem is interesting is because A, fractions, that makes it a little more of a challenge, and B, it's not 1 proportion, it's 2. Because we're talking about serving size, that's one thing. And then we're talking about calories, that's a second thing. And then we're talking about grams of fiber, that's a third thing. So we can't put 3 different things in a proportion. Proportions are only able to go apples to oranges, or the first thing to the second thing. So we could go potentially between, and I said potentially for a reason, calories and grams maybe. But unfortunately, we don't know how many calories or grams for the second scenario. We only have 100 calories from the first scenario and the 4 grams from the second scenario. So this is like if we had a table of values, or a proportion table, that is to say. We got calories, we got grams, and then we got the size. So the first scenario is we have a third of a cup. Hold on for 1 second. More dog fun. Okay, so we have a third of a cup. That was the first scenario. So if you need to label them like scenario A, scenario B. So A, B. So a third of a cup provides 100 calories and 4 grams of protein. It's not protein, it's fiber. And when I wrote grams here, I could have instead of written fiber or grams of fiber, remember, the words don't matter as long as you can correctly associate what they are. Instead of calories, I could have actually written the more technically correct name, kilocalories, but no one ever says that. Another word for calories would be energy. Calories is a specific unit. Energy is what calories give you. All right, scenario B, we know that it was a half of a cup, but we don't know how many calories. So we could write a C for calories if we wanted to, and we don't know how many grams of fiber, so I could write an F for fiber. So this is me setting up a proportion table. Did I have to do that? No. I still could have done everything using my words, which I will ultimately show you as well. But the point I was trying to make is you couldn't use just calories and fiber because both of them are unknown in that second scenario. You remember, you need 3 of those numbers to be known when you're setting up your proportion. All right, so if I wanted to draw a box, say this way, and remember, you don't draw it around the labels. You shouldn't have a box going up into your labels like that. That would be bad. So we could go 1/3, and I know this is annoying because it's a fraction, but sometimes life is annoying, over 1/2, and then equal to 100 over C. So again, this is the top left, this is the bottom left, then the 100 and the C are very obviously labeled. So when you cross multiply, CM for cross multiply, this is what you're going to get. You take the 1/3, let me use colors. You'll take the 1/3 times the C, so you get 1/3 times C, and then you take the 1/2 times the 100. So you go equals 1/2 times 100. Well, half of 100 is 50. You can use a calculator. Really, we'll always want to emphasize the fact that you should know how to add, subtract, multiply, divide fractions. We've talked about some of those things already. We didn't really talk about multiplying because it's the simpler case. You're just reducing tops and bottoms. 2 goes into 2 once and into 150 times. That's the idea there. There's no LCDs with multiplying. Now on the left side, the 1/3 C doesn't simplify. It's still just 1/3 times C. Now, the main types of proportions we've seen looked more something like, I'm going to scroll down just a little. This is what it typically looks like. You get something like 5x is equal to, I don't know, 100. And then you say, okay, well, that's 5 times x, so we divide both sides by 5. And you end up with x equals 20 after that. Because that was 5 times x, we had to divide both sides by 5. That was the typically, that's the way we see it 99% of the time, honestly. But that's not what we have here. What we have here is 1/3 of C. This 3 is in a bottom. Numbers in bottom count as being divided. So this is a division of 3, which means we need to multiply both sides by 3. So we take 3 times the left and 3 times the right. So 3 times 1/3 C equals 3 times 50. Those 3's would cancel, and you just get your C on the left side. 3 times 50 is not 50. Sorry, I was saying 50, and it made me write it. It's 150. So it seems like it should be 150 calories. Now, remember, C stands for calories, so that's the unit, 150 calories. You can ask yourself, does this make sense? Well, we went from 1/3 of a cup to 1/2 a cup. Now, you might be thinking, oh, we went from 3 to 2. That means it's smaller, so the calories should be smaller, but no. Those 3's and 2's are in the bottom, and as we'll be discovering sooner than later in the quantitative reasoning class, the bigger the number in the bottom, the smaller the answer, because you're dividing by something bigger. The bigger you divide by, the smaller your answer will be. Think about taking the number 100 and dividing it by 2. You'd get 50. Think of, instead of dividing it by 10, 100 divided by 10 is 10, smaller number. We increase the bottom, means it decreases the answer. So that's the opposite of here. We're going from 1/3 to 1/2. The bottom's getting smaller, which means the answer should get bigger. So yes, this does make sense. Let's see if it's right, because that's the first thing they want, 150 calories. And we got it right. Next, they want the grams of fiber. So we can go back to using this setup. We're no longer using, that's not what I clicked. Erase, please. There we go. So now I want to draw a box. Now that we know this C is 150, I want to draw a box to be able to find the F. Now, I could certainly do this, and I didn't round that number, so honestly, this isn't even bad because this 150 was not rounded at all. It was exact. It would be perfectly fine to do the box that way to make our proportion as 100 over 150 equals 4 over F. However, I want to practice this fraction jazz a little more, and I also want to go along the idea that if we don't have to borrow, we don't borrow. And I don't mean borrowing as in like for subtraction. I mean borrowing number to number to number to number. So instead, I'm going to draw my proportion box like this, which means I'm ignoring all the center numbers and just using the 1/3, the 1/2, the 4, and the F. So we'll go 1/3 over 1/2, that was the left side, 1/3 over 1/2 equals 4 over F. I'm going to go a little quicker through this one. So cross multiplying, we'll get the 1/3 times the F, and that'll be equal to the 1/2 times the 4. Half of 4 is 2, so 1/3 F is equal to 2, and then we multiply both sides by 2, right? Question mark, question mark, question mark. Well, 2 and 3 don't reduce. This is a case of we got to be careful and pay attention. You know I love to do those. So that 3 is a denominator, is the denominator, so that's why we multiply both sides by 3. So those 3's will cancel, giving us our answer of F is equal to 6. Let's see if it's right. Remember, that would be 6 grams of fiber, and it is. So if you want to get into the nitty-gritty, remember that with proportions, the basic idea is if one thing doubles, the other thing doubles. Well, you can't really see that here, but the 100 calories in one scenario went up to 150. That's a 50% increase. We'll get into how that number comes about later, but that's a 50% increase. Well, if the fiber went from 4 to 6, that's also a 50% increase. So those things have both increased by half of what they originally were. That's what a 50% increase means. All right, so right. Give me 1 minute. Okay. So now that we've done that, we're going to go back to the 2.2 material. It'll feel more like going forward to the 2.2 material from where we just were, but the past or present or future tense isn't what matters. What matters is that we're here and we're doing it. All right, so going back to the weighted average. We said that the weighted average formula is a bunch of sums in the top and a bunch of sums in the bottom, but there's also products in the top. So we said that the weighted, oops, I want highlighter. The weighted average is equal to data 1 times weight 1, then plus data 2 times weight 2, and then plus, and I'm just going to abbreviate from here, data entry number 3 times weight number 3, plus data number 4 times weight number 4, and then plus, and you just keep going and going and going for however many datas and weights you have. And you have to have as many datas as weights. So you can't have 5 data elements and 17 weights. You can even have 5 data elements and 6 weights, or vice versa. They have to match. There's a one-to-one relationship. Each piece of data has to have a weight. And then the bottom is just the sum of the weights. So there's no products in the bottom. It's just weight 1 plus weight 2 plus weight 3 plus weight 4 plus, and then you just keep going. So again, the top, the fancy name for this is a sum product because it's the sum of a bunch of products. The bottom is just a sum. Now you might find that there is an Excel feature called sum product that you can use, And in instances where it would be relevant, you most certainly could use it, but there's also ways to avoid using it. And you can learn about that moving forward. Maybe we'll address one of those issues in a month or two, something like that. So again, this is our formula that I have told my Math 154 students that they have to memorize. We're not going to be given a lot of formulas in this course. The only real big crazy formulas we see are once we hit chapter 9, and I do pretty much give all of those formulas on a formula sheet for testing. But while we're generally just multiplying, adding, subtracting things, we're not going to assume that we ever get these on some formula sheet. Now, again, you can make Excel do things like this for you, and that's really nice, especially for keeping track of your own grade in your Math 154 course. But what we're going to do today is about 4 problems where we just practice doing this by hand, because while it's nice when Excel is able to do things for us, it's also important that we understand how to do it ourselves for when our computer is down or when we might not trust the answer that Excel gave us. That whole does it make sense aspect. Okay, so the first problem we're going to do is going to have nothing to do with grades, because I like to change things up, because as I've said, these don't have to be just with grades. Example 1, a store sells tickets for $5 and buzzers for $20. Just 2 random items, tickets and buzzers. Tickets to what? I don't know. Buzzers for what? I don't know. We're just buying tickets and buzzers. So if you buy 10 tickets and 5 buzzers, what's the average cost of your purchase? Let me say average cost per item. I just wanted to phrase that a little better. So we have a store that sells tickets for $5 and buzzers for $20. These could be apples and oranges. These could be PCs and Macs, obviously not for $5 and $10, but you get the point. These could be 2 items of any type of prices of any size. But then what we're going to do is we're not just buying one of each. If we bought one of each and you wanted to know your average cost per item, you would take 5 plus 10, I'm sorry, 5 plus 20, and you'd get 25. You divide by 2 because that's your number of items, and you get $12.50. So if you bought one of each, your average price per item would be $12.50. And that's because the $5 makes the average a little lower, the 20 makes it a little higher, and that $12.50 is between those two. Now that aspect is extremely important, that your answer for any type of average has to be higher than the smallest amount and lower than the highest amount. In fact, I'm going to write that down above the example, again, just as a very important memo, a J memo, also known as just a memo. Any average should always be greater than the lowest, as well as less than the highest, assuming 2 different prices, 2 or more different prices. If they're all the same, then the average is what they all are already. If I say we're selling apples for $5 and oranges for $5 and the average price is $5, that would be the same. So my point here is, any answer for example, number 1, no matter how many, I have part of my screen blocked, so that's why I keep pausing. If I take away this 10 and this 5, and I said it was 1,000, and I said it was 2 buzzers, no matter what numbers I make these, the answer to example 1 can be no smaller than $5 and no bigger than $20, because again, those are the lowest and highest prices. And we were buying 10 tickets and 5 buzzers. Just want to fix that. All right, so everything's back to how it was originally. Now, the initial challenge for a lot of people, and sometimes for crazier examples, maybe even a challenge for a more seasoned student, is figuring out which of these things is the weight and which of these things is the data. We like to say that the weight is what's going to make the data have more or less of an effect. So we got the $5 tickets and we're selling 10 of them. So is it buying more or less tickets that would make the average closer to that, or is it increasing or decreasing the price that would make the average closer to the number of tickets or the number of buzzers? See, when you try and think about things the wrong way, it doesn't feel like it makes sense. And if you do the math the wrong way, the answer generally is not going to make sense. So for this example, we're going to do it the right way and the wrong way. I'm not going to say which one is correct initially until we get the answers and ask ourselves the whole, does it make sense kind of deal. So let's see. Actually, I want to do that one in red. All right, so for the left version, we're going to call the weight. What are the two different things? We have the number of items purchased, which are the 10 and the 5, and we have the costs, which are 5 and 20. So let's say for this blue one, and I'm not using blue for right or wrong necessarily. I know you might think that this red one's automatically going to be wrong, but I'm not saying that. Maybe I want to do it the opposite way just to throw you off, if that's what you're thinking. Sorry, this cough is never ending. So we have costs and we have number of tickets. Let's say that we think the weight is the costs and that the data, which really is just an arbitrary name, data. You can call these elements, you can call them a lot of different things, but this would be the, let's say the count or the number purchased. So my point here is that I'm going to do this whole thing a second time where I swap what I call weights and data. So we're going to do all the math for the blue one, then we'll do all the math for the red one. But when we do the red one, I'm going to say that the weight is the number purchased and that the cost, I'm sorry, that the data is the cost. All right, so blue version only for now. The weight is the cost and the data is the number purchased. So the costs are the 5 and the 20. And the number purchased in respective orders, the tickets were 10, and then the buzzers were 5. So if you did your weighted average formula with this particular labeling, which I'm not saying is right or wrong yet, again, here's your formula. You're just taking your data times your weight, plus your data times your weight, plus your data times your weight. Now I can't take the cost for tickets times the number of buzzers. You got to make sure you're going tickets with tickets, buzzers with buzzers. So that's what I mean by the little ones and the little twos. Keep your apple data with your apple weight. Keep your orange data with your orange weight. Keep your banana data with your banana weight. All right, so we said that the weight, and I'm going to try and do them in the same order that you see up on the formula. So I'll go data, then weight. So the data we said was the number purchased, which for the tickets was 10, times the weight, which is the 5, plus, so again, that was the number of tickets and the cost per ticket. Now we'll do the buzzers, which there were 5 buzzers that we bought for 20 each. And then we divide by, so again, the 10 times the 5 right here, this was the tickets. The 5 times the 20, that was the buzzers. And then the bottom we're saying is weight 1 plus weight 2 plus weight 3. There's only 2 sets of data here, so it's just weight 1 plus weight 2, which we call the weights the costs, so we go 5 plus 20. Now again, I'm not saying whether this setup is right or wrong. I'm saying let's just see what we get if we do it this way. All right, so weighted average. 10 times 5 is 50, plus 5 times 20 is 100, and then over 5 plus 20 is 25, but I'll wait till the next step to actually show that. 50 plus 100 is 150, 5 plus 20 is 25. And then we're going to do 25 into 150, which is 6 times. Now, the weighted average is supposed to be an average cost per item. So this is saying that our average cost per item, if it's right, is $6 per, or $6 each. I'll give you a minute. Now, let's do the red version where I've swapped what I called the weights and the datas. So our weighted average, again, it goes, scoot up here a little bit, data times weight plus data times weight plus data times weight. So we're going to go data first, which this time I've called the data the cost, and the weight I've called the number purchased. So we go the cost, and we're going to go tickets first again, which is $5, times the number of tickets purchased, which is 10. So again, this was for your tickets. Then plus. Now we'll do our buzzers, which the cost was 20 and the number of buzzers was 5. So 20 times 5 all over. And now we're saying that the data is the costs. So we're going to add up the data is the costs, but the bottom is the weights. I was saying that wrong. The bottom is the weights, and we said the weights of the number purchased, which are the 10 and the 5. So we're going to divide by 10 plus 5. Now, before I move on, I just want to compare and contrast what this looks like versus what this looks like. The bottom is drastically different. The bottom of the left one is 5 plus 20. The bottom of the right one is 10 plus 5. The tops, however, are not different. And you might say, well, yes, they are. This is 5 times 10 and this is 10 times 5. This one says 20 times 5 and this is 5 times 20. So yes, they are written in a different order, but remember that with multiplication as well as addition, the order you do them in doesn't matter as long as it's just addition or just multiplication. In other words, 5 plus 2 is 7 in the same way that 2 plus 5 is 7. 5 times 10 is 50 in the same way that 10 times 5 is 50. So 5 times 10 here is the same as this 10 times 5. This 20 times 5 here is the same as this 5 times 20. So that's what's interesting. No matter which thing you call the data and which thing you call the weight, the tops will always come out identical. However, and this is the most important aspect, the bottoms will always come out different because the bottoms only have what you call the weights. So in the red version, we've got 10 and 5, which were the number of tickets or buzzers purchased. But in the blue version, we have the 5 and the 20, which were the prices of the tickets and the buzzers. And again, we haven't said which one's right or wrong yet. That's not what we've addressed so far. I'm just kind of getting you used to seeing what you have and how to deal with it. All right, so now we'll finish the red. So the 5 times 10 and the 20 times 5, those are both 50 and 100. No surprise, as we just mentioned. But the bottom is 10 plus 5, which is 15. 50 plus 100 is still 150. Again, the top is the same. And then the bottom is 15. And 150 divided by 15 is 10. So this process says that the average cost per item is $10 each. Now, when you come across these problems and you do them the different ways like this, if this is the experiment you need to do to learn this a little better and to get a better understanding, very often one of these answers will be outside of even the realm of possibility. As we already mentioned earlier, the average always has to be between the greatest and lowest prices, or number of things if that's what you were looking for, which it's not. So 5 and 20, that means that whatever average we get has to be between 5 and 20. It can't be any smaller than 5, it can't be any bigger than 20, and both of our possibilities are in that window, unfortunately, but I did that intentionally. One answer was 6, the other was 10. Both are between 5 and 20. So now what we got to ask is, which one is more likely to be the correct answer? Which answer makes more sense? Because here's how weights work. If you buy one item and 10 items, so if I bought 10 tickets and only one buzzer, the thing that you buy more of is going to have a bigger effect. The thing that you buy more of, or the thing with the bigger weight, is going to have a bigger effect on the average. It means the answer will be closer to the average. So yeah, we bought 10 tickets at $5 per, but we also bought 5 buzzers at $20 each. So the answer shouldn't be too close to either of these because we got a pretty decent spread of the items. It only favors the tickets 2-1, but the buzzer price is significantly more than the ticket price. So these 5 buzzers at $20 each should bring up the average more than just $1. This seems too low. Now, if we only bought one buzzer, I would say this is more of a possibility. If we only bought 2 buzzers or even 0 buzzers, I would say this is more of a possibility. Because again, the thing that you're buying more of is going to have a bigger effect. So yes, we are going to be closer to the ticket price than the buzzer price, but we're not going to be like way closer. $10, that's $5 away from the tickets. It's $10 away from the buzzers. That's a little more in between and just feels more appropriate. So you might think that the blue one was going to be right, but it actually is incorrect. The correct answer, the correct process, not just answer, because that's the important aspect, was this. So the weights were really the number purchased, the data was the cost. So in this scenario, it's actually more of the thing that you can control that's the weight. And whenever we talk about an average cost, this is how things always work. The data is the cost of the items, and the weight is how many you purchase, because you could, in theory, if you have free will, decide to purchase more or less, which would cause the average to change. So if I wanted to buy instead 100 tickets, that would make the average much closer to this $5 than it would the 10 or even the 6. That average would probably be like $5.1 or $5.2 if we still only bought 5 buzzers. So with these weighted averages, when you get stuck in a corner, what can you do? Exactly like we just did. Do it one way where you call the data one thing and the weight one thing, and then do it the other way when you flip-flop them. And when you get your 2 answers, see which one makes more reasonable sense. And it's that type of process that'll help you get a deeper understanding of this and hopefully be able to label weights and datas correctly out of the gate. I've had students ask, well, wouldn't the weights just always be the percentages in an item that has percentages? Well, first of all, this question had no percentages, so that doesn't help. Second of all, no. In fact, with grades, the weights and the datas can both be considered percentages, because when we say, oh, I have a 76 on a homework, well, that's a 76% if your teacher is grading out of 100, because anything out of 100 is always a percent. And most teachers do those things. Now, if you have a teacher that says, all right, well, this assignment's worth 150 points, they're actually using a weighted system. They're just not telling you what the weights are. They have a hidden system from you. Now, your teacher, if they're not a math teacher, they might not realize that it's a weighted system under a 100-point scale. Still, it's just been arbitrarily changed, but that doesn't matter. They might say, oh, well, the whole semester's out of 1,000 points and this assignment's worth 150 points. Well, that's 15% of your grade, because 150 divided by 1,000 is 15%, or 0.15. So it's pretty easy to convert things to percents. As we were doing in 2.1, we showed that we can convert anything to anything using proportions. Okay, so with that being said, let's go to 3 problems, actually, assuming we have time, that will be a little more relevant for what feels like the class when you want to keep track of your grades. But again, this is something that you can use in the real world in more places than you might ever imagine. All right, select example 2. Bob's class assigns 40% for homework, 40% for quizzes, 20% for the final. Currently has an average of 92 homeworks, 75 quizzes. What is his current, in all caps for emphasis, grade? It won't always be in all caps later. Current grade is different from a final grade. Final grade accounts for everything. A current grade does not account for the stuff that has not happened. Here's the problem when most people try and calculate their averages. They'll say, oh, okay, well, the midterm I haven't taken yet, the final I haven't taken yet, so what do I do? Where do I put these numbers? Easy answer, you don't. You don't put the final exam anywhere in your formula because it hasn't happened yet. You don't put the midterm in your formula because it hasn't happened yet. You don't put the project in your formula because it hasn't happened yet. Once those grades happen, then you can insert them into your formula. Now, again, I mentioned to my Math 154 students that I did create an Excel gradebook that I'll be distributing to students and kind of telling you how to use it, just one or two subtle details. But I'm also considering making an assignment where you have to turn in your Excel file and show the calculation by hand. I'm not saying I'm doing it. I'm strongly considering it. I strongly consider a lot of things that I don't always do, but sometimes I do them. So I think that would be a really cool homework just to make sure that everyone not only knows how to type something in Excel, whoop-de-doo, especially for something that was pre-formatted to do the job for you, but also to understand the calculations. Okay. So with grades, weight is always what a section is worth, not the grade given. So one teacher might decide to call midterm 50% of the class and final exam 50% of the class. So all they have is a midterm and a final. Wouldn't you love that in this course? So one teacher decides they're equally weighted, 50-50. Another teacher says, yeah, I'm going to call the midterm 10% of the class and the final 90% of the class. I'm sorry, you're going to have to hold on about 30 seconds. Sorry about that. I can't even remember what I said last. Okay, the 90 and 10. So one teacher says a midterm is 9% and the final is 10%. Well, that teacher, this second evil teacher, has made the final much, 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 much more important towards the final grade. So a student who gets a 0 on the final in the first class, they still have the midterm for half their grade. So let's say they got 100 on the midterm, then their grade is going to be a 50%. But that second class, if a student didn't take the final, they would only have a 10 because let's say they had got that 100 on the midterm, that's only 10% of the grade. It's not a very large effect on the grade. That final was 90% of your grade. It was weighted 9 times as strong as the midterm, but you've lost all those points. So that's 90 points that you'd have a 0 on, which would mean you'd only have a 10 in that situation. So that is why it is what the grade is worth, which we are typically given as a percentage, that is the weight. Your grade isn't what is really going to have that cause and effect issue here. It's the weight. Yes, your grade still has an effect. The higher the grade you make, the better grade you earn. But it's the weights being how much they're actually worth that makes more sense. Okay, so I need to move this. There we go. Our weighted average. Again, I'm going to go in order of the formula written before. So data times weight, data times weight, data times weight. Completely arbitrary. I just want to be consistent with the formula as you see it that you are supposed to memorize. So data times weight. What on earth is happening in my home today? I'm sorry. Are we having fun yet? Okay. Weighted average is data times weight, data times weight. All right, so the 40%, the 40%, and the 20%, those are going to be our weights. I'm just going to write W and then point, 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 and then these are our datas, this 92 and this 75. Okay, so I gave you the 92 for the homework. I gave you the 75 for the quizzes. But Mr. Beckner, you didn't give us the final. You said the final is 20% of your grade, but you didn't give me a final. How can you give me 3 weights and only 2 pieces of data? You just said earlier you have to have the same number of weights and datas. Exactly. So don't use the weights that don't have a data. So because there is no final, here's what we do. We don't even worry about this for right now. I'm not saying erase it from history. I'm not going to just leave that permanently scratched out. I'm just saying we are not going to use that for the context of this problem. So we're only going to use the homeworks and the quizzes. So we'll go homework, which is the 92 times its weight, which is 40%, plus then the quizzes, which was the 75 times its also 40%. They were coincidentally the same number, just like our homeworks and quizzes. So again, I'm just going to label really quickly. This was your homework, and this was your quizzes. So we don't do the finals. We don't do the final because it would be plus what's the grade times the 20%. If you don't have that number, you don't use it. All right. So over, this is the bottom is just the sum of the weights. And you might say, oh, okay, well, 40 plus 20. So here's your homework weight. Here's your quiz weight. I'm going to pull out the red because this is wrong. Plus here's your final weight. But we didn't put the final stuff up here. We didn't put it because it was an unknown grade times its 20%. So if you don't have the final exam portion up here, you don't have the final exam portion down here. So all I really need is all the blue. So again, we're only using the things we have data for. All right. So the 92 times the 40 is going to be 3680. In fact, I'll pull out a calculator. This. Go. So 92 times 40. You might say, but that says 40%. Shouldn't that be 0.4? We'll get to that in a minute. So we got that 3680 I mentioned. plus the 75 times the 40. So 75 times 40 is going to be 3,000. And then 40 plus 40 in the bottom is just 80. 3680 plus 3,000 is going to be 6680. Just have to add the 3's divided by 80. And then we'll do that division. 6680 divided by 80. 83.5. That is our average currently. It does not account for the final exam because we have not had the final exam. Well, it would just give us a 0 because it hasn't happened yet. Well, that's going to tell you that your weighted average is significantly lower, because then you would have that 20% in the bottom that you're dividing by, and it would make your average smaller. Now you got to ask yourselves, with anything in this class, does it make sense? Well, the lowest grade we had was a 75. The highest grade we had was a 92. So our average must be no lower than 75 and no higher than 92. It should be somewhere between them. And it is. 83.5 is between 75 and 92. And you can even take this further if these are different weights and say, well, which one should it be closer to? If the homework is with 80% of the grade, then your final average or temporary average should be closer to the homework grade of 92. But these are actually equally weighted, which means it would be equally between these two. Now, when you have 3 or 4 or 5 elements that you're finding an average of, it becomes much more difficult to make sense of the average in terms of that aspect. But you can at least say it still has to be bigger than the smallest and smaller than the biggest. So yes, this does make perfect sense. If you had instead done this the wrong way, which we don't have time to do, if you had divided by the 92 plus 75 instead of the 40 plus 40, you would get, remember the top won't change, so it's still 6680. But now I'm going to divide by the sum of the grades, which 92 plus 75 is going to be 167. So I'm going to divide by 167. So the math you're seeing me do right here is incorrectly calling the weights the actual grades we earned. And we get a 40. That would not make sense at all. How is our average of 40 if the lowest grade we have, the lowest average out of a section, is a 75? How would we have an average of 40 if the lowest grade we earned for a category was a 75? It wouldn't make sense. So you'd say, oh, I goofed, I divided by the wrong thing probably, or I did something in the calculator wrong, or who knows? There's a lot of things that can go wrong for everything that can go right. So let's try another one of these. Example 3. I'll pull my back here. Jane's class assigns same weights as Bob's. Maybe they're in the same class. Jane currently has an average of 98 on homework, 95 in quizzes, and an 81 on the final. This is her final grade. So I've given grades to all categories this time, which means we can calculate a final grade. I could have just made this a second part of the previous one, and I said, all right, well now, or I could have made a second part of the previous one and say, all right, well, Bob earns 82 on the final exam. Now, what's his final grade? And then you can just throw in the extra calculations. All of this would still be here. You would just have this plus 20% here, and then plus whatever I say times the 20% it's worth. That would be the difference of calculating, say, a midterm grade versus a final grade. You just have all the same stuff from before, but you throw in your extra category. All right, so Jane's weighted average. I'm going to go homework, quizzes, and then tests. So her homework was a 98. That was the data, times the weight is the 40%, plus then the quiz grade, which was a 95, times its weight, which was also 40%. We said the weights are the same. and then plus the final exam, which she earned an 81 on, times its weight of 20%. So again, the first product is homework, the second product, quizzes, the third product, the final. Then in the bottom, we just divide by the sum of the weights, which again, for this type of problem, the weights are always what they're worth, not what you earned, the 40, the 40, and the 20. So 40% plus 40% plus 20%. See how similar this looks? It still has the 40 and the 40 from before. It still has this times 40, this times 40. The grades are different because we have two different people. The only thing that's really new is this person, we have a final exam grade, which created these elements here, the finals weight times its data, and the finals weight in the bottom. All right, so let's do some math. We got the 98 times the 40, which is going to be 3,920. Just do this so I don't have to keep messing with that. Equals 3,920. Then we have the 95 times the 40, which is 3,800. Then the 81 times 20, which is 1620. Then divided by 40 plus 40 plus 20 is 100. Don't you dare put that in a calculator. Don't you dare. All right, so now let's add up the 3,920 plus the 3,800 plus the 1620. Now, before I hit enter, I want you to notice that, look at these numbers. The homework and the quiz grades were pretty close to each other, and these numbers are pretty close to each other in the high 3,000s. This final exam grade is not that far off, but it's only worth 20%, which is why this number is like half as big as these. If this final had been worth 40%, this number would have been in the $3,000s, and it would have felt more appropriate in size. With this class, the final is weighted lower, so these points, these effective points, are lower. All right, so when we add, we get 9340. Then we're going to divide that by 100, which ends up being 93.4. Dividing by 100 just moves a decimal left twice. So that would be our final average. And then you ask yourself, does it make sense? Every problem you do in this course, you need to train yourself. Ask yourself, does it make sense? Every single problem. Every single problem. Every single problem. So our grades are, in terms of categories, 98, 95, and 81. So clearly we can't get an average that's lower than an 81. Clearly we can't get a final average that's higher than a 98. It should be somewhere in between them. And 93.5 is definitely in between those. That's about the most sense you can make for something with more than two categories. I wouldn't really ask you to think about it further, but if you are working on becoming more numerate, you could say, all right, well, which should we be closer to? Well, we did really, really good on homeworks and quizzes make up 80% of the assignments. So on 80% of the assignments, we did really, really well. So that should have a bigger effect than the much smaller 20%, 1/4 the size, where we did slightly less well. Yes, a B is still good, but not as awesome as a mid-tier A. So because we have so much more weight in the good area, I expect my grade to be more good, aka better, and it is a 93.5. If we swap these weights, or let's say we swap these grades, let's say this was like an 81, this was like an 82, and then this was the 95, then our average would be closer to the mid-80s because our worst grades would be taking over more than the good grades. All right. Before we do our last example, I want to show something that I addressed earlier. And I said, well, these are percentages. Wouldn't this be a 0.4, a 0.4, a 0.2, etc.? Yes, as long as you're consistent, and yes, you can do it that way. So what I want to do in red is, and this is not a red for wrong, this is a red for the same thing. Now, it's only for the things that were written as percentages. Don't do that with your grades as well. That's going to confuse you. So leave the 98, 95, and 81. So 98, 95, 81. Those things are all staying the same. It's the weights that I'm going to convert from percentages to decimals. So instead of 40%, that's 0.4. Instead of 40%, that is also 0.4. Instead of 20%, that's 0.2. But you have to be consistent. If you're doing 0.4, 0.4, and 0.2 in the top, you do the exact same in the bottom. You cannot mix media. You cannot do percents in the top and decimals in the bottom. And if you do this math, let's see, 98, I'm gonna go a little quicker, times 0.4 is gonna be 39.2. 3920, 39.2, interesting. Plus, if I do 95 times 0.4, I get 38. 3,800 versus 38, interesting. If I do 81 times 0.2, you get 16.2 instead of 1620. Huh, interesting. They're all off by just a few decimals. And in the bottom, here's what's really cool, and here's my favorite aspect of using the decimals instead of the percents. This is my favorite way to do it because of this. 0.4 plus 0.4 plus 0.2 is 1. And dividing by 1 means you don't really need to write it. And if you add up those numbers, 39.2 plus 38 plus 16.2, you get 93.4, the same answer. So with things like grades, when your weights are written as percentages, do you have to write them as percentages? No. Can you convert them to decimals? Yes. Do you have to write them as decimals? No. You can leave them as percents. Just don't do percents in the top and decimals in the bottom or vice versa. Be consistent and we're cool. Now, again, on your own time, what I would encourage you to do is going back to this problem where I did it right one way and wrong one way, which I said out loud for later, but do, I would say example 2 the wrong way. I already gave you the answer of 40. So if you do example 2 the wrong way and you get 40, then you know you did it the wrong way, the right way. I know that sounds weird. But you will at least know you got your incorrect answer in the way I expected you to. And then you go, oh, 40, that doesn't make sense. Now again, you don't have to do these the wrong way, but I think that just might benefit you to see the math done the right way, to see it done the wrong way, and to understand why one works and the other doesn't. All right, example 4. Let's go back to Bob. I'm sorry, not Bob. We got a third student here, Alex. Not that you care. Alex. Alex's class assigns 20% for homework, 20% for quizzes, 20% for each of 3 tests. He's earned a 100 on all homeworks. He earned quiz grades of 95, 90, and 80. Has 2 test grades, 85 and 94. What is his current average? Give you a minute to write that. All right, we got more categories this time. You might say, no, we don't. Homework, quizzes, tests. Yes, we do. I said 20% for each of 3 tests. So that's not saying that your tests are worth 20%, or 20% each. Each is a very important word here. It means there's 3 tests. That means there's 3 categories. Test 1 is 20%, test 2 is 20%, test 3 is 20%. Whenever we talk about weights as percentages, if when assuming you're looking at the full class, they better add up to, you guessed it, 100%. Something else that's happening. Well, Mr. Beckner, what the heck? You gave me multiple quiz grades. You can't do that. You're supposed to give me the average. Says who? Do I give you your quiz average in this class? You know I don't. Do I give you your homework average in this class? You know I don't. You got to calculate those things on your own to then have the grade that you multiply by the homework weight or the quiz weight. So the first thing you have to do is find your average homework and average quiz grade. Well, the homework is very obvious. It's 100. Why? Because he earned 100 on all the homeworks. Quizzes, we have a 95, a 90, and an 80. And you go, okay, well, the quizzes are worth 20% each. Nope, doesn't matter. We don't care about any of these weights right now when we're looking at an independent category, and all of these in the independent category are weighted equally. No quiz is worth more than another quiz. So this is the old school average where you just add them up and divide by the number of entries. So we just take the 95 plus the 90 plus the 80, and there's 3 grades there, and we divide it by 3. This is the exact same issue you would have with your homework grades, your quiz grades. And by homework, I mean your Excel is one particular type of homework, and then your regular math lab as one type of homework. Okay, so we got 95 plus 90 plus 80. And then we divide that by 3, so that's 265 divided by 3, and we get 88.33333333333333. Let's just call it 88.3. I'm going to round to the nearest tenth here. If this was a homework problem, of course I would tell you how to round, but we're just using an example, so I'm saying round to the nearest tenth. So that's the quiz average, of which has a weight of 20%. Okay, so we have our homework average, we have our quiz average. You might say, well, now you got to find your test average. No, you don't find a test average because this 20% is for each test. So that 85 gets its own 20%. This 94 gets its own 20%. If we had taken our third test, it would get its own 20%. So our weighted average, we're ready to calculate. I'm going to go in the order of homework, quiz, test 1, test 2. So homework, quiz. We said our average was a 100 because they were all 100s, times its weight of, let's go with the decimal version so we can mix it up. So that was 20%, which would be 0.2. And we get, again, with percent to decimal conversions, you just take the decimal, which if you don't see it, it's there for the percent, and you move it left twice. So that's why it's 0.2. So the same for all of those. All those 20% will be 0.2s. So then plus our quizzes, we said our quiz average was an 88.3 times its 0.2 for its weight. Plus test 1, we earned an 85 times its weight of 20%. Plus test 2, which we earned a 94 times its weight of, you guessed it, 20%. So there's our, what we call sum product. Data times weight, plus data times weight, plus data times weight, plus data times weight. Divided by the sum of the weights, which are the literally called weights for the class, all the 20%. So we have the 20% for the homework, right? Nope, because I just wrote it as a percent. Got to write it as a decimal. We got to be consistent. So 0.2. So that's the homework 20%. Here's the quiz 20%. Here's test 1's 20%. And here's test 2's 20%. I would not put in a third one for tests, a fifth 0.2 in total, because this would be test 3, and we don't have a grade for test 3. So that's why it's not there. All right, so 100 times 0.2 is going to be 20. Show the work. The 88.3 times 0.2 is going to be 17.66. The 85 times 0.2, 17. The 94 times 0.2 be 18.8. And that's it for the top. The 4 categories, remember test 3 not taken, so nothing written about it. And then 0.2 plus 0.2 plus 0.2 plus 0.2 is 0.8. 2, 4, 6, 8. Add those up. 20 plus 17.66 plus 17 plus 18.8. We get 73.46. Now somebody might think that's the final grade because they forget about the bottom. They forget to divide by the 0.8. Classic mistake. And you might say, well, Mr. Beckner, that's not a 1. You're right, it's not a 1 because the class isn't finished. The bottom is only a 1 or a 100% if you actually finish a class. We've only accounted for 80% of the grades. So divide by 0.8, and we get 91.825. Let's just round that to a 91.8 because I said 1 decimal earlier. So we have an A, or more specifically, Alex has an A. And you might think that, oh man, that first test being an 85, I'm cursed to get a B now. There's no way I can come back. Well, actually, because you did so well on the homeworks, because you did fine on the quizzes, pretty good, almost an A, and your test 2 was a 94, it padded your grade a little bit. And that's exactly what for my QR classes, with the my math lab homework, the participation, the project, those are all supposed to be padding elements. Honestly, with practice, the Excel homeworks are supposed to pad your grade as well. And that's why I like keeping the midterm and final at only 20% each, just so things are, a lot more equitably distributed. All right, so we're going to call it there. So again, this is what I encourage you to do with your own averages. Especially go ahead and try it for now, and then eventually, again, if you're my 154 student, you'll get that grade book Excel file, and then you can put all your My Math Lab grades in there. You can put all your Excel grades in there, all your quizzes in there, and then you'll have something that'll keep you up to date all semester with what your grade is. All right, so if you have any questions, please email me. Besides that, take